Hello and welcome back. This is Halifax, and in the last video we talked about how we can dump shaders, how we can extract them from an engine, which are the different states in which a shader can be extracted, the normal one, the default one, the one that we get after we inserted the stereoscopy effect into that shader, and so on. Basically all the modifications get reflected in that shader. And now that we found some of the shaders that are problematic, we basically want to disable them or initially, and later on we want to change them, to alter them so they render properly in stereo 2D. And in the last video I showed you how you can use the shader dump function and the shader pair function of the shader compiler to search and find a specific shader. In this video, basically we are going to talk about how we are going to add our modified shaders and swap them at runtime. So basically only the shaders that we found will be the ones that we are going to use. So we found those shaders, we are going to modify the source code of those shaders, and we are going to swap it or upload it at runtime, sorry, instead of the one that normally gets generated. I'm going to show you in a couple of seconds what I mean exactly. So here I still have Broken Age. We found this shader, if you remember, number 3, 6, 20, 23 and 26. Each is responsible for something, as we saw. Now if we open the configuration file, we are still in the development mode. So if we open the configuration file, set the stereo injection or the vertex stereo injection point option as being disabled, and launch the game. We are going to delete all the shaders. So set it as disabled. The reason I'm doing this is because now the game will launch in with 3D vision enabled, but it will still be 2D, so we get everything nicely and stuff like that. And most important, we get all the shaders without any modification. So number 3, for example, see, there is no stereoscopic injection in this shader. So for the purpose of this tutorial, basically we are going to let most of the shaders render in 3D, and only some of them, the ones that we actually found, 3, 6, 20, 23 and 26, these ones will still be rendered in 2D. We are going to say we want them to be rendered in 2D. So in order to do that, sorry, that's something else. In order to do that, we are going in the main game folder, we are going to create a folder called shaders, and from the debug shaders folder we are going to select number 3, both vertex and fragment, number 6, number 20, number 23 and number 26. So we are going to copy and paste them in the shader folder. Now at this point you can go into each shader and modify each shader as you see fit. But for the purpose of this tutorial, I'm not going to do that. We'll talk about how we can fix shaders in a couple of videos later. So yeah, that's just a comment. Sorry. So now we have all the shaders that we found. We need to tell the wrapper to use these shaders from this folder. In order to do that, back in the configuration file all the way at the bottom, we can enable that one. Can put it back to onto the vertex stereo injection. All the way to the bottom, you'll see a vertex stereo exception section, which basically tells specify exception pairs of shaders. Vertex plus pixel equals a shader program. The order is the program ID, the vertex ID, and the pixel ID. Program ID is always required. If a vertex ID and a pixel ID are set to 0, the shader swap will be done only based on the program ID. So I'm going to show you in a couple of seconds exactly. Otherwise, the program ID, the vertex ID, and the pixel ID must match with the ones created by the engine or by the game. So in our case, like I told you in the last video, we see that the program is number 3, number 6, 20, 23, and so on. The vertex ID is number 1, the pixel or the fragment is number 2 for shader number 3, number 4 for shader number 6 for the vertex, number 5 for the pixel on program 6, and so on. Basically, we see that each shader program has a different ID for the fragment and the vertex. So in this case, we will need to specify all 3 parameters. So we'll start with the shader number 3. So shader pair, program is number 3, vertex is number 1, fragment is number 2. Number 3, vertex is number 1, fragment is number 2. Now you'll see that 3 underscore vertex underscore 1 dot glsl is actually the name of this file. Here basically you can say, you can rename the file and you can put whatever name you want, both here and the actual name of the file. So for example, I'm going to modify this one by vertex 3. So in order for the wrapper to find it, this name must match. And now we are going to do the same thing for all the other shaders. So number 6, shader number 6 is actually vertex 4, fragment 5, here it was 6, it is 6 underscore vertex number 4, here program is 6, fragment underscore 5, and the next shader, which is number 20, we get 20, we get 20, the vertex number is number 18, fragment number 19, so vertex is 18, fragment is 19. We have 2 more, 23, 23, vertex is 21, and pixel is 22. So we get 23, 23, 21, 22, and the last one, which is number 26, 24, and 25. 26, 26, vertex is 24, and fragment is 25. So now that we defined all the shaders that we basically want to apply or to swap, the wrapper will open each individual shader, will get the source code from this file, and will do some other magic in the background basically. So now we have 3D vision enabled. We say we do want to enable this stereoscopic effect in all the other shaders. So basically now this string and this information will only apply to all the shaders except these ones. So now that we have this, if we launch the game, you will see that some part is rendered in 3D, some is in 2D. You will get the menu in 2D, everything except that one there, something's wrong. You get basically everything that we defined in these shaders get, see, the menu, everything is in 2D. Now the reason we did that is because now we can basically change the convergence of the actual game without interfering with, see, without interfering with the menus and the UI and the HUD and so on. So basically this doesn't necessarily apply to the HUD and the UI. Basically you can find any shader for anything using this method, and you can swap them. Now if you want to play this game at the moment, probably because this is just the menu, it will not bother you that much having something into the overlapping the 3D experience in the background basically. And therefore most of the times you don't want to leave 2D shaders in a 3D rendered game or environment. So we will need to add some stereoscopic effect to them, but the purpose of this video was to show just after we extracted or we found the shaders how we basically hook them with the wrapper. So I'm going to show you one last thing. If I look here, 3 is responsible for some UI parts, is responsible for the main menu font, is responsible for the I'll pick sorry, I'll pick number 26, and number 26, the vertex, I'm going to open it and I'm going to close that one, and back in the archive of the wrapper that you downloaded from the website, you'll find a folder called shaders. So if you enter in it, you'll find 2 files: disable a pixel shader, disable a vertex shader. If I open the disable pixel shader file, you'll get something like this. I'm sorry, not a pixel, I wanted to do the shader, the vertex, because we are actually modifying a vertex shader. So it says append to the last line of the main function GL position is a vector of 4, because GL position is actually a vector of 4. So this is our vertex. Append to the last line of the main function. So the main function basically exists between the brackets here, this bracket and this bracket. So we append that line, we write it there, we save the file, we can close the file then, and we are going to open the file, the game again, and now we are going to hit continue, and as you can see, no font, no text is available, while the other parts of the menus or in the shaders are still present. We modified shader number 26. If we look here, shader number 26 is responsible for the other text. The other text is basically the text that we see in the menus, but is not the main menu font or the main menu text. So now if we go back in shader number 26 and we delete this line and we say that the actual position on the x-axis is, we add 5 units. We add 5, we save it, we close it, we relaunch the game. You will actually 5 may be too much as you can see. So let's try a different, a smaller value. Probably 5 is very big in this case. So let's add a 0.5 on the x-axis. And as you can see, 0.5 added will move the text to the right. The reason this happens, it's because in OpenGL the most or the top left corner is actually 0, 0. So adding something on the x-axis will move everything on the right, while removing something from the x-axis will move everything on the left, like a shift. You can say it as a shift, or you can see it as an offset. So basically I showed you how a little modification gets reflected, and as you can see, this only happens only on that shader, and probably this shader, and basically everywhere this shader is being used. See? So I'm going to remove that. I'm going to leave the shader blank. Before we wrap up this video, I want to talk with you about the other option that you might see here, because here we said there are two options. Either we say the program number, the vertex shader number, and the fragment shader number, or we can say something like this. In this case, the vertex, the program must match only this number. And you'll ask why this is needed. Well, I'm going to show you exactly why. I'm going to select another game, an optimized game engine, which I've talked about in a couple of videos before, and that's Wolfenstein or id5 engine, which we have it here. And I've dumped the shaders again, and I found some shaders which you can see here using the same method that I showed in the last video. So basically using this exactly the same method, I found these shaders responsible for the main UI, some part of the UI, another part of the UI, another part of the UI, and the HUD, which is basically in the game. So I dump all of the shaders. Now you can see Wolfenstein has significantly much more 500, while Broken Age had 20 or 50 overall, so 10 times more. So now I want to compare the shaders from one game with the shaders from the other game. We have vertex 3, so program 3 vertex 1, program 3 vertex 1, program 3 fragment 2, program 3 fragment 2. Until here everything is the same. Now I move to the next shader, which in this case is program 6 vertex 4, program 6 fragment 5. Here instead we get program 4 vertex 1, fragment 2, program 4. As you can see, each program, absolutely each program, creates vertex ID 1 and fragment ID 2. See? Everything. 1, 2, 1, 2. So we could probably put something like this for Wolfenstein, I mean, but this will not work, and I'm going to show you exactly why it will not work, because it's easier to show than trying to explain. I don't want to save that, so I'll go here, I'll open this one, I'll open this one, I'll make the folder like before called shaders. I'll select 162, 169, 170, 71, and 75, and I'll copy them in the shader folder. So now we are going to say, oops, my fault, we are going to say 162, 1, 2, 162, 162, vertex 1, fragment 2. And we have another one, and another one, and another one, and another one. So it's 69, 69, 69, 70, 70, 70, 71, and 75. Oops. 75. So we've added them back. We enable this option again. We have 2D vision enabled. Everything is looking nice. We start the game. And yeah. And you get this problem. Oh, this problem actually, my bad. We've talked about it in a couple of videos before. It's actually this option, enable failure info. If enable, will display the vertex shader in which the stereoscopy wasn't inserted. And we've talked about this option quite in a lot of detail and why we don't want to insert stereoscopy in blank or pass-through shaders like this one, where GL position is actually 0, 0, 0. Basically, this one says there is no GL position. Like I showed you in this video, saying something like this basically disable that shader. So, just going to kill Wolfenstein for the moment, and because we don't want to see that one, I'm going to put it back on false, and now we start it again. And let's see. Shader compile failed. And you get something funky like this, error output, nothing, and the game crashes. That's because when I specify something like this, the wrapper will look for a vertex shader with ID 1 that currently exists. Now, because the way the shaders are created here, you can clearly see that every time a program is created, the engine deletes the shaders. So then when the next program is created, basically the same shaders are, or the same shader IDs are being assigned again. So it's creating vertex 1, fragment 2, creating program 3, deleting fragment 2, vertex 1. Program 3 remains created. Then for the next one again, and for the next one again, and so on and so on and so on. So that's why in this case we just need to look on the program ID. Because when we are looking for the program, the shaders, the individual shader pairs or shaders aren't there anymore. They got deleted. They don't exist anymore. So we just want to swap the current sources that exist in each individual shader program. Now if we launch it now, well, what do you know? No error. And we get the funky, awesome Wolfenstein music, which I'm going to put it a little bit like there. And we forgot something. Oh no, we didn't forget anything, because that's the UI. Like I said, that's the UI. So the UI is in 2D, like you can see. Everything is in 2D for the UI. That's the whole UI, the shaders that we attached. And now we get actually in-game where you will see that the game renders in 3D. You can see the double image, and you can see we can increase the convergence, and the convergence only affects, as you can see here, the actual game without the menus being affected, and so on and so on and so on. Now you'll also notice in this game the colors are very funky. We definitely hooked or modified a shader, see, a vertex shader, which we shouldn't have. Some colors in complex games, basically when you're computing something, you don't usually compute it in one shader, but you compute it in a series of shaders. So sometimes the color is direct dependent on the position of a certain element. By hooking that specific shader that calculates the position of an element based on which the color is being calculated, we get this funky stuff. So as you can see, funky, funky, funky. Now using the same method as before, we can find that shader. Now I already have that shader, and for the sake of simplicity and trying to basically is number 97. So number 97 needs not to be modified. So we don't need to modify it. That's why I showed you in this video some shaders don't need any modification. And what you get when you don't modify them is the plain unaffected behavior. Either is 2D, or like we are going to see now, we will get our color back. So if I go here, I'll just add it here. I'll say 97, I believe. 97, 97. I hope yeah, it's 97. So if we start the game again, as you can see, no compile errors, nothing, everything's fine, looks awesome. Start, we get the 2D menu, we resume the game. Blutknochen und Fleisch wie Eisen, or I don't know exactly how that is pronounced, but we continue, and something didn't work. Or I know why. I know why. I know why. Remember that I told you, see? Stereoscopy. Remember that I told you exactly that the debug shader functionality always outputs the current version of the shader, the one that is running. So this shader, the content of the shader is the one from the previous run, where we already saw the colors being messed because we added stereoscopy. So if we just remove the stereoscopic option and the uniforms here for the stereoscopic, and we leave it blank like normal, and we save it and we launch the game again, hop, come on. We will get the game. Game will start, no errors, nothing. So it will normally start. Loading profile settings. Resume. Here we get the normal colors while everything is in 2D. The game, no UI, no HUD, everything is 2D because we specified 2D shaders without any stereoscopic. Now, like I said before, if you will go here and you'll find the shaders that we are swapping, the 162 for example, it will contain the plane 2D. That's because we are overriding the shader here with our own custom source. So if we dump it again, we get what we actually load, which is exactly the same thing, the 2D variant of it. So I'm going to close the game. So regarding this option, I'm going to enumerate it or to talk about it again, because I want to be absolutely sure that people do understand how this thing works. So the simplest way to explain it is you always require a program ID, which you get from the actual shader. It's 23 here, 20 here, 15 here. For the fragment and the vertex ID, sometimes you do need them, sometimes you don't. The reason, or when the case in which you need them, is when you'll get shaders like this: vertex 1 for this program, vertex 4 for this program, vertex 21 for this program, vertex 48 for this program. This is blank, basically. There is nothing attached to it. That's why it's 0. So vertex 46. So in this case, for this one, you'll need to say 47 program vertex 46 and shader 0. You're not actually going to load the shader here. So in this case, 0 will work because it's actually 0. But for this one, it will be 36, 34, 35. Exactly like this. 36, 34, 35. And of course, the actual sources files that contains the source code for the individual shaders. So yeah, if you get distinct vertex and fragment IDs, you need to specify those IDs here. If you get repetitive vertex and fragment IDs like you get in id5 engines, that's valid for Wolfenstein and for Rage, and I don't know any other game that's using this engine so far. So if you get something like this, vertex 1, vertex 1, vertex 1, vertex 1, vertex 1, vertex 1, and so on, repetitive patterns, you notice that if we do put here 1 and 2, you'll get a compile error, because the wrapper will try to delete something that is not there anymore. So in this case, we specify 0, which means ignore the current ID of the vertex and the current ID of the fragment. I just want to delete everything from this shader and create a new fragment and a new vertex with my source and recompile and redo everything in the background and use this one, what I specify in these files basically. So I really hope that's clear, because it might be a little bit or it might seem to be a little bit confusing, but I really hope you understand what I'm saying. And once you understand this, it will be simply as pie basically. So yes, that's about this video. In the next video I'm going to tell you how we are going to enable additional convergence presets, how to bind keys, and how to read the convergence within a game and stuff like that. And with that video I expect we will end the easy part of the tutorials. Then we'll go into the advanced section where we're going to talk about fixing shaders and shader compiler, real-time shader compiler, and many other awesome things. But if you are following this tutorial step by step, including the next video, basically you will be able to make a limited fix, or how should I say, a fix in which you will enable 3D you will render everything in stereoscopy, and the elements that you, or shaders that you want, you can either leave them in 2D like the menus, or disable them completely like I showed you in this video. So if you have a shadow or a wrong lens flare or something that you don't know how to fix and you just want it removed, I showed you in this video how you can do that. So until we see in the next videos, cheerios guys.